Okay, last time we discussed several examples using the definition of the trig functions of any angle, which I commonly call the point on the terminal side definition, where you're given a point xy and you calculate the distance r from the origin to the point P, and then calculate your trig function values. Sine of theta, for example, is the y coordinate divided by the length r, cosine is x over r, tangent y over x, and so forth. You get a lot of misunderstanding about the terminology of a unit circle. A unit circle simply means a circle whose radius is 1. So if you take a unit circle approach, what you're doing is deliberately letting the value of r equal 1. Well, that would in turn alter this side x, as I'd proportionally have to divide it by r, and this side y would proportionally be divided by r, and then your new point would be x over r, comma, y over r. So a lot of people find this convenient because the new points ordered pairs would then represent the cosine of theta and the sine of theta. Now, to give you a more specific application, you could take any point. In this particular case, you're given a point xy, which is on the unit circle, so you already know the minute you see this terminology that this implies that r equals 1. Okay, you already know the values of a and b, which are the x and the y coordinates of P. So P is the ordered pair -18/17 and the y coordinate 15/17. And so what you get here, if you go back to our original definition, sine is still y over r. It's just when r is 1, the sine is the y coordinate. Cosine is still x over r. It's just that when r is 1, cosine values the x coordinate. Tangent is the y coordinate divided by the x coordinate. And if I do the algebra there, I would notice that their denominators reduce away. Cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. And cotangent is the reciprocal of tangent. So I would say at a minimum, know the firm definitions for those three guys in the x, y, r realm, regardless of whether you're taking a unit circle approach, and then the others you can get from the identities.